Hello, my name is Miko Stulajter, and for the past 3 months I have been working as a 3D Experience Scientific Visualization intern with the BIOVIA R&D software engineering team. I have enjoyed my time with BIOVIA, and here I'll share some of the projects I have worked on and why I loved working with BIOVIA this summer. During my time, I worked closely with the BIOVIA Scientific Visualization team. I worked on two main projects, one adding new features for the users to utilize, and the other was prototyping a possible future feature. I added several new UI/UX features that enable the user to get high-quality images and videos of their structures. I added a resolution control panel that allows for the control of the download size and dimensions of images and videos. There are several predefined resolutions, including HD and Ultra HD, and a custom resolution option. The custom resolution option lets you set a slider for the number of pixels between 128 and 4096 for the height and width. I also added a crop interface that allows the area that is downloaded to be controlled. The crop area is designated by the blue box and is draggable and resizable to allow the user to have lots of flexibility. There is an option to auto crop to the molecule, and when you edit the crop region, there is the option to reset the crop region to either the entire preview or the auto crop box that you had at the beginning. New background color options were also added. The option of a horizontal gradient and a radial gradient were added along with different options to control the colors of these gradients. You can control the two colors in the gradient along with the ratio of the two colors to give you many possible unique gradients. The color picker lets you choose any color for the two primary colors, while the ratio is a scale of 0 to 1, where the extremes make one color more dominant versus the other. The other options that we have is the coverage area, which controls whether the gradient extends across multiple molecule views or is independent in each molecule view. The other major project that I worked on was implementing a prototype of a 3D to 2D web-based tool, which was created to see if it is possible to get a highly interactive 3D to 2D tool that runs fully in the browser. For a static image, having a tool to create a 2D representation will be much clearer than a static image of a 3D structure. To do this, the D3 open source JavaScript library for data visualization was used for the creation of the 2D representations. D3 uses a physics-based simulator to position visual elements, nodes, and links to create an image. The prototype takes in selected atoms and bonds in the molecule view along with non-bond interactions to create a 2D representation. The representation takes in atom distances from the 3D representation to create 2D pair constraints similar to a structure-based force field. In the prototype, individual atoms can also be dragged to get a custom 2D representation. Thank you, BIOVIA, and thank you to my supervisors and the whole BIOVIA R&D team for providing me support and guidance throughout my internship. I really enjoyed the variety of tasks assigned to me, being both research-based and pure software engineering. I appreciated how helpful, friendly, and knowledgeable everyone I worked with during the summer was, and during my internship I really felt like a part of the team. I learned a lot over the summer and wanted to thank BIOVIA one more time for giving me this opportunity.